So this is the diagram for how to draw uh, the reflection by a plane mirror. Okay, the question, draw a diagram to show the formation of the image by the plane mirror. So this is the diagram. As you can see, the ray which is 1 and 2 is the ray which is going straight and then coming back straight. 3 and 4 is the ray which is 3 is the ray which is incident on the mirror in a slanting way, and 4 is the ray which is getting reflected. And can you see 4 is appearing to come from point there behind, and thus you get the height of the object to be height of the image. So what are the properties? The height of the image and the height of the object are the same. The image will be laterally inverted, that is left will appear on the right and right will appear on the left in the mirror. And the distance of the image behind the mirror will be equal to distance of the object in front of the mirror. And these are the three main properties of the image formed by the plane mirror. So let's go to next. This is the erect. The last point is erect virtual image, because this is an erect image that you get and it's a virtual image. Okay, these are the key points. That's the answer for the first question. So let's go to the second question. Second question is this. Okay. A convex mirror of focal length 20 cm. A concave mirror is like this. Its focal length will be negative, its radius of curvature will be negative. A convex lens will be like this. Its focal length will be positive, its right, and radius is also positive to the right. Anything to the right is positive, anything to the left of the pole is negative. So now coming back to the second question, a concave mirror of focal length 20 cm is placed 50 cm from the wall. So you have a wall here. A concave mirror is placed in such a way that it's 50 cm from the wall. This whole distance is 50 cm. Okay, and how far from the wall should an object be placed? Okay, the focal length of this is 20 cm. And you know, therefore the radius of curvature is 40 cm, which is double the focal length. Supposing this is 20 cm and this is 40 cm, you can see that this will be the center of curvature and this will be the focal length. And so this is like beyond C. The wall is beyond C. So if the object itself is beyond C, okay, and now a concave mirror of focal length 20 cm placed 50 cm from the wall. How far from the wall should an object be placed so as to form its real image on the wall? So as to form its real image, which is an inverted image on the wall. So if you have to get a real image on the wall like this, which is an inverted image, that's what you get after reflection from, when the object then has to be between C and F. The object is between C and F and AB. The light ray goes and hits the concave mirror parallel to the principal axis and gets reflected back, passing through the principal focus. Okay, yeah. And another ray goes, I can also say, goes and hits the mirror obliquely at a point P. Obliquely at a point P. It will get reflected back also, making same angle. This is theta, this theta, and so it will get reflected back with the same angle, thereby forming an image here, and you get an inverted image. So the object has to be, this is B dash, A dash. It's an inverted image by the concave mirror, for which object has to be between C and F. Okay, and this object that you get here will be an enlarged real inverted image. And that's the diagram, and you understood. A concave mirror of focal length 20 cm placed 50 cm from the wall. How far from the wall should an object be placed so as to so you need to know this distance from the wall. What is this distance? That's the question. The object distance from the wall. First you need to know the object distance from the mirror. Mirror formula is 1 by F is equal to 1 by V plus 1 by U. And the focal length is minus 20, because focal length of the concave mirror is negative, is equal to 1 by V. You know what should be the V. V is minus 50, because it's again to the left of the pole. That's where your final image is. Plus you don't know where the object should be. So then 1 by U is equal to minus 1 by 20 plus 1 by 50. Taking this to the other side. 1 by U is equal to, let's keep it as 100. And 25s are 100 and 52s are minus 5 plus 2 is 1 by U is equal to minus 3 by 100. So U is equal to 100 by 3 with a negative sign. 3 3s are 9. and then again 3 3s are 9, 3 3s are 9, 10 3 3s are 9, and 33.3 or something like that. So that is the distance of the object, which is object distance is this from the pole. That is the object distance, and u is 33.3, say approximately. The distance from the wall is what they're asking. So its total distance, you know, is 50, right? Between the wall and the mirror is totally 50. So 50 minus 33.3. Supposing you keep it as 7, this 9, 6, and this is 4, 16.7. That will be the centimeter. 16.7 centimeter will be the distance from the wall. I hope you understood why we are subtracting. That's the second question. So let's go to third question. Third question is okay, an object is placed at a distance of 40 centimeter from the concave mirror. An object is placed at a distance of 40 centimeter. Concave mirror, again, focal length of the concave mirror is minus 15 centimeter. The concave mirror's focal length is definitely my negative. An object is placed 40 centimeter from the concave mirror. So let's draw a concave mirror. The focal length is here 15 centimeter. This is the radius of curvature C, center of curvature, which will be at a distance of 30 centimeter. The object is placed 40 centimeter, which means the object is beyond C. When the object is beyond C, the image will be between C and F. Okay, the object is beyond C, the image will be between the AB is the object. Any ray parallel to the principal axis will pass through the principal focus. Any ray falling obliquely at P at the pole, making an angle theta at the pole, will get reflected back also obliquely, and you will get a reflector also back obliquely. So you can draw it like this, and so thus you get an inverted image here, which will be a diminished image. It's a B dash A dash. I hope you understood the diagram. So this is the way you have to draw. To be more clear, I'll just draw it like this. Okay, in such a way, this is also theta, this is also theta, and you get a B dash A dash. So this is the diagram. So an object is placed at a distance of 40 centimeters. So u is equal to minus 40 centimeter. Obviously, it will be beyond C. Okay, and focal length is minus 15 again because it's concave mirror. If it is displaced through a distance of 20 centimeter towards the mirror, the object is going to be displaced through a distance of 20 centimeter towards the mirror. The initial distance of the object is 40, no? The new u dash is going to be, move it to 20 to the right, it will become minus 20 centimeter. New u dash, okay? How much distance is the image displaced? The question is about how much distance will the image be displaced. So in the sum, you just write the mirror formula. 1 by f is equal to 1 by v plus 1 by u. You know that the focal length is minus 15 and the object distance initially is minus 40, with which you find v1, which is minus 24 centimeter. Now the object is moved by 20 centimeter, right, towards the mirror. So your new object distance is also minus 20. The new object distance here is minus 20, second part of the sum. You know the focal length, you know the new object distance, which find the final image distance, which is v2 is equal to minus 60 centimeter. You know that the first image was at minus 24 centimeter. The second image after the displacement is minus 60 centimeter. How much is the image moved? Is this image distance minus that image distance of minus 60 minus of minus 24. So it would have moved through a distance of minus 36 centimeter away from the mirror. Okay, this is the question and that's the answer for it. So let's go to next sum. Convex lens. So convex lens of refractive index 1.5 has a focal length of 18 centimeter in air. Calculate the change in the focal length when it's immersed in water. Okay, you know that when it is in air, the refractive index so much. When you dip it in water, the refractive index will be 4 times this. I taught you this in class. F dash is equal to 18 into 4. 8 4s are 32, 4 1s are 4, 72. That will be the new focal length when it is immersed in and so what will be the Question is, what will be the change in the focal length? So then you have to just subtract it. I told you the convex lens, when you place it in air, the ray of light will come to a convergence quickly because it travels faster. But you place it in water, the variation of the densities here is less. So when compared to this with the lens, glass with air and glass with water, the variation of the densities is less. So then here it tends to travel slowly. The water, it will travel slowly. When it travels slowly, it travels a longer path, so then therefore the focal length becomes more, and the focal length is 4 times the initial focal length is what we have learned. Always just remember it. Because here the variation is more, the bending is more, we can say, because it's from denser to rarer. It's from so then here the bending is more, but here it's denser to less rarer because it's water. The bending is less, and so the focal length is more. I hope you understood. So then it's 4 times, you can mug it up. And so then the difference in focal length is what they're asking. So then minus up to 72 minus 18. 72 minus 18, it will be 12, so it will be 4, and this is 6, and 54 centimeter will be the change, delta f, or the change in the focal length. Let's go to next question. The fifth question. No, the fifth question is what I've done now. Okay, the fifth question is what I've done. So let's go to sixth question. Sixth question in the assignment sheet is omitted some. So let's go to seventh question. 2 thin lenses of power plus 6 diopter plus 6 diopter and minus 2 diopter in contact. So 2 lenses are in contact. Okay. So this shows that the focal length is positive, and this shows the focal length is negative, because focal length and power are simply the reciprocals. And so then in meters though. So this is positive, shows that it's convex lens, and this negative shows that the next one is a concave lens, and they both are in contact. That's what it means. A convex lens of okay, then minus contact. What is the focal length of this combination? So when they ask you for focal length of the combination, it's 1 by f is equal to 1 by f1 plus 1 by f2. Okay, so that's the formula for combined focal length. So when they give you a sum like this, 1 by f is equal to 1 by f1 plus 1 by f2, but don't use that. But because what has been given is only the power, not the focal length, and you know that focal length is the reciprocal of power. Power is the reciprocal of focal length. So use the power formula. So what is given here is P is equal to plus 6, P1 plus P2. Put P is equal to P1 plus P2 for the combination. So it's plus 6 minus 2 is plus 4 diopter. Okay, plus 4 diopter. And you know that the focal length of the combination should have been 1 by 4, but that should have been then 100 by 4, because we need to calculate the focal length in centimeter. But 4 diopter is based on the value being in meters, the focal length in meters. So 1 by 4 will become 100 by 4 in centimeters. So can I write 25 centimeter to be the combination's focal length? So that's right, kids. 25 centimeters, right answer. Very, very important sum. When they give you power, calculate the total power. Once you calculate the total power, then find the effective focal length, equivalent focal length, or whatever, because of the combination. I hope it's clear. Let's go to next question. Next question is eighth sum in the assignment sheet, which is also omitted. Let's go to ninth question. A double convex lens. A double convex lens means it's like this. Maybe they are talking about lens makers. Biconvex lens. Any question that starts with biconvex or double convex, I can always relate to only lens maker's formula. A double convex lens of refractive index 1.5 has both the surfaces of equal radius, which means this side also it's r and this is also minus r, but sign conventions are taken. So because for this face it's plus r and for this face it's minus r, and both of them are of the same radius. Definitely they're talking about lens makers, because in that only you'll have 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2, wherein you know that One radius is positive, other radius is negative, so plus r, it will become 2 by r. So 1 by f is equal to mu minus 1 into 2 by r. In refractive index of this is given to be 1.5. So 1.5 minus 1 of the glass with respect to air, 2 by r is equal to 1 by f. What else is given in the question? Let me read the question. A double convex lens of refractive index 1.5 has both sides of equal radius of curvature of 20 centimeter each. So you know r itself is 20, capital R itself is 20. So then 0.5 into 2 by 20, which will make it 0.5 by 10, which is 5 by 100, and 5 to certain 20, 1 by f. Therefore f itself is 20 centimeter. This you get the focal length. Okay, calculate the an object of height. Okay, so it's not over. A double convex lens of 1 okay, and object of height 5 centimeter is placed at a distance of 15 centimeter from the lens. So you're placing an object of 5 centimeter. Is placed at a distance of 15 centimeter from the lens. Calculate the size of the image formed. Answer, they have given it to be 4. I don't know. Okay, I just got the focal length. First you need to get the focal length. Once you get the focal length, so you know 1 by f is equal to, but the thing is, normally when the radius of curvature is not been given, right? Yeah. Object distance is given to be minus 15 centimeter. You get the focal length, and then at 1 by f is equal to 1 by v minus 1 by u, where 1 by f is plus 20 is equal to 1 by v minus of lens formula is the minus sign, and u itself is minus 15, so it will become plus 1 by 15. So 1 by v therefore is 1 by 20 minus 1 by 15. This itself can be written as 60 because 23s are and 15 4s are. So 3 minus 4 is minus 1 by 60. Therefore v is equal to minus 60 centimeter. So image will be formed at minus 60 centimeter, which again shows that it's on the minus 60 centimeter, which shows that it's going to be, and the focal length is 20. Can you see the focal length is 20? Which means, can you see that this is where the focal length is? So object is between f and optic center. Obviously you'll get an enlarged virtual erect image, such a big image behind it. Okay, so that's what it means. So you get the v to be minus 60 centimeter, which is to the left side of the pole, and such an enlarged, it's such a distance, and you know it has got to be highly magnified, which is height of the image by height of the object should be equal to v by u, which is 60 by what was the object distance? Was 15, right? 15 4s are 60. So you know the height of the image 4 times the height of the object. So you can write it like this. Magnification is simply hi by ho, okay, which is given by v by u. So you might think, why wasn't it minus 60 and minus 15? Minus and minus get cancelled, so it makes sense, and this is 4 times its magnification. Calculate the size of the image formed. You know the height of the object is 5 centimeter. So put here 5. So height of the image is 4 into 5, so 20 centimeter. So that will be the height of the image. Let's go to next question. 10th question. A ray of light falls on a triangular prism. So let's draw a triangular prism. You know, it's not given equilateral glass prism, just given triangular prism, in such a way that the deviation of the emergent ray is minimum for the prism. When will the deviation be minimum? You know, the deviation formula is I plus E minus A. But this deviation has to be minimum. It will be 2I minus A, because I will be equal to E, and R1 is equal to R2 is equal to A, or 2R is equal to A. So then, you know, 2R is equal to A is first condition, and this is second condition for minimum deviation to occur, because that's when this ray will go parallel to the base and emerge, so that if you do a normal, your I and E will be the same, and R1 and R2 will be the same. Okay, so then a ray of light falls in triangular prism such a way that the deviation is minimum. Draw a ray diagram for this case and write the relation between the angle of incidence and the angle of emergence. Relation between angle of incidence and the angle of emergence for the minimum deviation, you know, I is equal to E. That's what they mean. So you have to just write that, okay? So that derivation you all know. the relation between the angle of incidence and the angle of emergence. In the case of minimum deviation, I should be equal to E. You can also draw this diagram where this will be parallel to the base. That's when R1 is equal to R2, and let it meet here. And obviously the deviation angle is this angle, which will be minimum, because the condition for this graph of delta versus I goes like this and comes like this. It reaches minimum of delta M when I is equal to E and R1 is equal to R2 is equal to R. And just complete this and say that's it. But since they have asked you to derive that I is equal to E, how do I do that? Okay, since to prove I is equal to E, take this. This is a refractive index of glass with respect to air. For this phase, it's entering from air to glass, so rarer to denser. So mu is equal to sine I by sine R1. Okay, now this phase, it's entering from glass to air. So it's 1 by mu of glass with respect to air is equal to sine I, which happens to be sine R2 here. That's the incident ray, by sine E, which is the emergent ray. But you know that when you reciprocal this, you get sine E by sine R2. This is your equation 1, this is your equation 2. But since you know R1 is equal to R2 for sure, because this ray is parallel to the base, that's a condition for this, right? R1 is equal to R2, then obviously sine R1 is equal to sine R2, therefore I is equal to E. So angle of incidence, this is how I would do it, okay? So that completes this question. Okay, next question is the 11th question. So let's go to 11th question. A ray of light falls on a transparent right-angled isosceles prism made up of glass of refractive index √2. Draw a ray diagram for the prism when the incident ray falls normally on one of the equal sides of the prism. Oh, this side is equal to this side, right? So then how do I draw the one of the equal sides of the prism? So the right ray is falling normally on one of the equal sides. It will go straight undeviated until it falls in the other face. And in this phase, let's do a normal. Okay, and you know that this is a right angle prism, so this angle is 45 degree, this angle is 90 degree, therefore you know this is 45, and therefore this will be 45 with a normal here, correct? With this normal. So you know angle of incidence is 45, refractive index of the material is √2, and the critical angle IC is equal to sine inverse of 1 by mu, this is 1 by √2, the IC is equal to therefore 45 degree or pi by 4, and that is my critical angle, which means IC has to pi by 4, 45 degree. So this ray will graze along the separation because the incident angle incidentally happens to be only 45 degree and the critical angle is also only 45 degree. Therefore, it will graze to the separation. Draw the diagram for the prism when the incident ray falls normally at one of the faces. Oh, this is how you should complete this diagram. So let's go to 12th question. 12th question, with the help of a suitable ray diagram, derive mirror formula for a concave mirror. Derive lens formula for a convex mirror. Okay. Suitable. Let's do a mirror formula for the concave mirror. Okay. So let's do a mirror formula. Let's write a concave mirror. This is the principal focus. This is the radius of curvature. Let's consider any position. Okay. Let's consider that the object is beyond C. A ray parallel to the principal axis. After reflection will pass through the principal focus. Any ray falling obliquely at P will get reflected back obliquely with the same angle, such a way this is theta, this is also theta. Reflected back obliquely, and you get an image in such a way that you get an image. Make sure you're drawing a straight line here. You get an inverted image, diminished image, B dash A dash. Okay, that much you should be very clear with. So then this is your image. And now, in order to get the mirror formula, what should you do? Okay, so then I have to construct this is pole, right? I'll construct a Z B dash which is equal to AB. Can you see AB is the object distance, object height? I'm constructing a ZB dash in purple color. So construction. What are you constructing? A ZB dash which is equal to AB. Now once you do this, you can locate similar triangles and write the sides to get the mirror formula. I am locating a triangle. Can you see here is one triangle and here is another triangle, and they are similar because 90 degree, 90 degree, and this is theta and this is theta, and so then I'll write the comparison of these two triangles, the proportionate sides. So you know that the proportionate sides will be AB by A dash B dash, which is the image object height and image height, by the object distance and image distance, which is BO, BP. What is it? BB dash. Huh? Okay, so BB dash. No, we can't write BB dash because B dash is already here. Let's write ZN. Let ZN be equal to AB. When ZN is equal to AB, by construction, you can write AB by A dash B dash, which is the image distance, is equal to BN, which is measured from the pole normally, BP, but N is so close to P, so BN by B dash N. Okay, and you know that Bn is nothing but object distance, which is minus u. B dash n is nothing but image distance, which is minus v. So this is your equation 1. Minus and minus can be cancelled. Next, identify another similar triangle. Now the red color similar triangles is over. You identified A, B, N and A dash B, N. Comparing triangle A, B, N and A dash B, N. You got this. Okay, now I have to identify some other triangle. Let me do it in different color. Okay, some other similar triangle. So what do? I'm just saying, can you see a triangle which is here? And this triangle here are similar because you have a vertically opposite angle. So comparing B dash F A dash triangle and ZNF, both the triangle, you know that the vertically opposite angles are equal, so you can write the proportionate sides again. But here I'll write Zn instead of AB on the first equation. I'm writing Zn because Zn by construction is equal to AB. So Zn by A dash B dash is equal to that triangle's adjacent side, which is Fn by B dash F. And you know Zn is also AB by A dash B dash. So therefore this is my second equation. What is Fn? Fn is this distance, which is the focal length, minus F. Then what is B dash F? Can you see? I'm going to write B dash F very carefully. Just notice B dash F is this distance, but all measurements are supposed to be made from the pole. So then this is nothing but this minus this. This is the image distance minus this, which is the focal length. And so then substituting, I'll get minus V minus of minus F. So then therefore it becomes minus F by minus V plus F. So this is my second equation. Can we equate 1 with 2? Because this is also AB by A dash B dash, this is also AB by A dash B dash. U by V is equal to F by V plus F. Cross multiplying UV plus UF is equal to FV. Now dividing throughout by UVF, 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 F and F get cancelled, V and V get cancelled. U and U get cancelled, F and F get cancelled, U and U get cancelled, V and V get cancelled. Thus, and the focal length should also be negative. Yeah, Fn by B dash F is equal to B dash N minus Fn. B dash N is the image distance, Fn is the object distance. So is equal to, oh, I forgot the sign convention, sorry. I forgot to put that it's minus F by minus V plus F, right? So that's the second equation, no? So cross multiplying minus UV plus UF is equal to minus FV, divided throughout by UVF, UVF and a UVF. F and B and B get cancelled. U and F and F get cancelled. U and B and B get cancelled. So thus you have minus 1 by F plus 1 by B is equal to minus 1 by U. You can take this, that's it, this to the side. So you get 1 by F is equal to 1 by V plus 1 by U, which is the mirror formula, and this is the way you should do after plugging in all the sign conventions. That's about a concave mirror. One of the positions is done. So next is also for a convex lens formula for convex lens. So let's take a convex lens. Okay, so you have F1 and 2F1. You will have F2 and 2F2. There'll be both sides because there's one curvature here, another curvature also here, right? So then suppose let's take a position where the object is beyond 2F1. Any ray parallel to the principal axis will pass through the principal focus. Any ray passing oblique through optic center will go undeviated, and the image will be formed between F2 and 2F2, and it's a diminished image, inverted image, real image. Okay, so in this you have to do the proof of lens formula, which is 1 by F is equal to 1 by V minus 1 by U, for which you would immediately construct here Zn or something like that, so that you can identify the triangles easily like previous sum. So now let's identify the vertically opposite angle here. Can you see a vertically opposite angle here and here? So then therefore this triangle will be similar to this triangle. So that's AB by A dash B dash is equal to adjacent sides, which is Bn by B dash n. The Bn is the object distance, but B dash n is the image distance. Again minus get cancel, you get U by V. So that is over. We have to identify some other triangle. Let's see which has got which triangle can I compare with. I can compare. Can you see a similar triangle which is in here, another which is here? Can I compare these two triangles? The green color lines that I have put, it's very easy. So then there's the triangle here. So it's Zn, which is actually by construction equal to AB. You can check it out in the diagram. Zn by A dash B dash, which is also AB by A dash B dash, okay, will be equal to the adjacent side of ZnF triangle, ZnF2 triangle, okay. Adjacent side is NF2 by the adjacent side of the other small triangle that I marked here is F2 B dash. NF2 is this, which is again the focal length of the convex lens itself, and F2 B dash is this distance, and you have to do all measurements from the pole. So you will have to do this distance minus this distance. This distance is image distance, to the right side is positive, and also focal length, which is to the right, which is also positive. So you have to subtract those two, so you will eventually get V minus F, even though it's because you're subtracting, correct? So now you can equate the first equation with the second equation. U by V is equal to F by V minus F, and cross multiplying UV minus UF is equal to VF, dividing throughout by UVF, the V and V and F and F get cancelled, U and F and F get cancelled, U and V and V get cancelled, 1 by F minus 1 by V is equal to 1 by U, but we are not supposed to get it as, you have to get it as 1 by V minus 1 by U, so something is not okay. Let's check what is a mistake. The focal length is positive, image distance is also positive. It's this minus this, V minus F is equal to U by V. Okay, B dash N is not negative, it's positive, right? It's V is on the right side here. So that's my mistake. So then you write it as U minus U by V, because one is negative, other is positive. So we are sorted. Okay, I hope you have corrected my mistake. So then therefore it will be minus UV plus UF is equal to FV, dividing through by UVF and UVF and UVF. F and F and V and V get cancelled. U and F and F get cancelled. U and V and V get cancelled. Minus 1 by F plus 1 by V is equal to 1 by U. Therefore, taking this to the other side, 1 by f is equal to 1 by v minus 1 by u. Make sure you're writing the right symbols and you got this answer right. Let's go to the next question. So next question is 13th question. 13th question. On one face of the prism with refractive index angle of 30 degree. Okay, so there's a prism, refractive index angle of refractive index, which means that is 30 degree, is coated with silver. One of the faces is coated with silver. A ray of light on the other face at an angle of 45 degree is refracted and reflected from the silver coating, which means silver coating is here. Because initially it's getting, for anything which is falling at an angle of 45 degree, the angle of incidence is 45 degree here. It's going to bend towards a normal. Okay, and it's going to fall like this. Okay, let's see. One face, okay, 45 degree is reflected and refracted first and then reflected from the silver coating and retraces its path. The key word here is retraces. If it has to retrace, it has to fall normally on the mirror. So I have to change this diagram. It has to fall normally. If it has to fall normally, the ray has to go and fall like this. That is when it will retrace. And this is where my angle R should be then. Correct? That's when it is falling normally. So this is also 90 degree. Yeah, okay, all that is fine. What is the balance of the question? So one of the faces is coated with silver. Angle of the prism is 30 degree. A ray incident on the other face at an angle of 45 degree is refracted and then reflected by the silver coating and retraces its path. Find the refractive index of the material of the prism. Here it is completely retracing. So you have to find the refractive index. If you can find this R, you can find the refractive index. Very simple. So what you do is, this is 90 degree, this 30 degree, therefore this angle has to be 60 degree. If 60 degree, then there's a normal here, and therefore you know R is equal to 30 degree. Once you know R is 30 degree, a refractive index for this face is entering from rarer to denser only. So mu is equal to sin I, which is sin 45, by sin R, which is sin 30. Sin 45 is 1 by root 2 and a sin 30 is 1 by 2. So it's 2 by root 2. So refractive index is 2, which is 1.414. So that's root 2 is the refractive index of the material. I hope you're clear. So that completes it retraces, means it has to fall normally. If you don't know this, you could not have done this sum. So let's go to 14th question. You are given 3 lenses, lens 1, lens 2 and lens 3. Using the given data, state which of the 2 lenses will you prefer to construct a best possible microscope and best possible telescope. They haven't taught you the microscope optical instruments at in your school, but they've asked you this question where they have given this combination of lenses L1, L2, L3, where the powers are 3D, 6D and 10D. These are the powers, and aperture is 8 centimeter, 1 centimeter and 1 centimeter. Okay, so which one will you choose for microscope? First of all, you should know how a microscope is constructed. Microscope is to look at microorganisms. So there's an objective which is smaller and an eyepiece which will be larger. This is how this is objective lens, which is near the object, because the light ray from the object is come from the left. Okay, so then this objective and this is the eyepiece. When compared to the objective, the eyepiece is larger size because its object is looking at object is nothing but a microscopic organisms. So that's about the microscope. So when you know that, what we can say is since the smaller lenses will be more curved and will have therefore lesser focal length. So anything which has got lesser focal length will have a greater power. So it will have a greater power. Okay, so we can say that okay, what is the question? I still haven't understood. Let me read it properly. So when they give you such a question, you know the telescope, I just told you microscope, says the objective, microscope, the objective is smaller. The smaller means smaller focal length. whereas the objective is smaller, the eyepiece is larger. So O means objective, E means eyepiece. Objective must have smaller focal length. Choose the one from the table which has got a smaller focal length, which has got the highest power will have the smallest focal length, because focal length and power are reciprocal. So when they say 10 diopter, that is lens number 3 is what you would use for objective for the microscope. And for the eyepiece is larger focal length. Larger focal length means least power. So we can choose 6 diopter as the power, so L1. So that's about microscope. In the case of telescope, you're looking at the sun and moon and all larger objects. So objective is larger, the eyepiece is smaller. Larger objective means larger aperture. Larger aperture, whichever has the largest aperture is the condition for telescope. So 8 centimeter, therefore L2. And for eyepiece, a small focal length, again you select a 10 diopter because focal length and power are reciprocals, and so L3. I hope you understood this answer. So let's continue with the next question. Okay, so coming back to this. Okay, next question is the 15th question. Let's see, a convex lens of focal length 20 centimeter is placed coaxially with a concave mirror of focal length 10 centimeter. Concave mirror, is it? At a distance of 50 centimeter apart. A beam of light parallel to the principal axis is incident on the convex lens. Find the position of the final image formed by this combination. It's a concave mirror, right? Concave mirror, yes, it's a concave mirror. Find the position of the final image formed by the combination. Draw the ray diagram. Okay, so you know this is parallel to the principal axis, which means it will pass through the principal image will be formed at the principal focus. The distance between them is 50, so this is going to form its first image at 20 centimeter. That's going to serve as an object. This is where my first image is, and that's going to, I mark it as I dash because it's going to serve as an object for the second mirror. So second mirror, the object distance is 50 minus 20, so object distance is minus 30 centimeter. So that's your object distance for the concave mirror. And what is the concave mirror formula? 1 by f is equal to 1 by v plus 1 by u. And the focal length of this, it's a concave mirror, is negative because you know the radius of curvature is to the right, to the left of the pole, and so focal length has to be minus 10 is equal to 1 by v. You don't know, you know u is minus 1 by 30, considering that the image distance and the object distance and the focal length are to the left. So 1 by v therefore is minus 1 by 10 plus 1 by 30. So 30 is LCM, minus 3 plus 1, which is 9, minus 2 by 30, which is 15. Okay, so V is equal to minus 15 centimeter. V is equal to minus 15. What is the meaning of that? For the second lens, the image is going to be actually obtained here to the left because it's negative, and it's going to be between this and this. So that's where your image will be. And would it be inverted and all that? I'll come to that later. So you know this is where the position of the foci. In the first case, actually you are if the object is at infinity, you'll get a point-sized image at the principal focus. Now this is going to serve as an object for the concave mirror and a point-sized image, and that's going to be at a distance of 30 centimeter, which is like beyond C, because the focal length is 10. Beyond C, between C and F is where you will get the image, and so it will be an inverted image. Yeah, so it will be an inverted image and it's obtained at a distance of minus 15 centimeter. But the answer here shows they haven't given the answer, right? A beam of light, draw the ray diagram showing the final image formation. So I have to complete the ray diagram. In that case, I'll have to do it properly. So then this is the image, and this is going to serve as an object for the second one. And but there's a point-sized image. So how do I complete this diagram? The point-sized image on a concave mirror. So once you know that V is minus 15, you know the final image is obtained somewhere here. So from the lens, what will be the distance? It's 50 minus 15. So it will be 35 centimeter to the right of the lens. Okay, to the right of the lens. This is what I would do. But this is what you get here, since it's coming from parallel to the principal axis. Okay, it's passing through the principal focus. So actually speaking, you're getting an image at the at this point, passing through the principal focus. So you're getting an image at the principal focus of this. Now how to complete this diagram? We have to draw this in an expanded way. For the concave mirror, you know that the focal length of the concave mirror is at 10 centimeter. So this is 10 and this is 20 so this 10 and this distance is 20, and that this is formed in such a way that the object is here, virtual object V dash is at distance of 30 centimeter. Okay, which is like beyond C. This is your curvature and this is the focal length. So supposing this is an object like this is going to be passing parallel to the principal axis and passing through the principal focus. Another ray is going to fall obliquely at P and it's going to get reflected back obliquely. In such a way you're getting a image here as an inverted image, and it's obtained at minus 15 centimeter. And this diagram I'm showing it separately. This has to continue here. Okay, this has to be fixed in here. Okay, and that's the position which we need to fit in. Or we can do one thing, we can just draw a convex lens here and say that the ray parallel to principal axis is passing through the principal focus, and this is where your object is installed. So this can be your diagram, and this can also be your diagram. I'm sure you understood. This is a perfect diagram of whatever they want us to do. You can check with their answer. They haven't specified what is the answer here. So let's go to next sum. Okay, so let's go to next sum. What's the question? A convex lens. This is sum number 16. A convex lens of focal length 10 centimeter is placed coaxially 5 centimeter from a concave lens. So 5 centimeter away from a concave lens of focal length, again 10 centimeter. We can write it as minus 10 centimeter because for a concave lens it's negative. If an object is placed 30 centimeter in front of the convex lens, its focal length is 10 means 20, 30. This is C, this is F. So at a distance of 30 centimeter in front of the convex lens beyond C, it will get refracted and form between C and F on the other side. Okay. Find the position of the final image by the combination of system. So you know that this is 30 centimeter. Yeah, and so then let's take this focal length 1 by F is equal to 1 by V minus 1 by U, whereas 1 by 10 is equal to 1 by V. You don't know, 1 by U is minus 30 because it's lens, it's minus or minus 30. 1 by 10 is equal to 1 by V plus 1 by 30. So 1 by V therefore is 1 by 10 minus 1 by 30, where 30 is LCM. So 2, 15, therefore you get V to be at plus 15, which shows that your image is going to be formed on the right side. Plus 15, this itself is 5. So 15 means it's going to be formed somewhere on the right side of this concave lens. It's 5 plus 10, 15, so you're getting somewhere here. And that's going to serve as an object for the concave lens now. And what will be that distance? 15 minus 5, so that V dash will be 10 centimeter to the right side of the optic center, so it's going to be positive. And the focal length of this second lens is anyway negative, so 1 by F is equal to 1 by V minus 1 by U, in which case your object distance is 10 centimeter, which is positive because this is this V dash that you're substituting, trying to find what is your V, and this is minus 10, which is the focal length. So 1 by V therefore is minus 1 by 10 plus 1 by 10, or we can even say this is 10, which is the object distance, which is at the focal length and the focal point, and so then the image will be at infinity. 1 by v is equal to 0, so v is equal to infinity. You know the final image will be obtained at infinity. So that's the 16th question. Find the position of the final image formed by the combined system. Okay, that's right. Let's go to, in my opinion, it's right. If there's anything wrong, you can come back and give me a feedback. You can also try these sums at home parallelly. Just don't copy from me. If you try sincerely, then you will get the final image to be at infinity. Let's go to next question. Next question is the 17th question. For the lens combination shown, there's a lens like this, a convex and a concave lens. A lens combination shown, no, that is this is plano concave. This is a plano concave lens. It's a plane surface here. Okay, so what can you say? For the lens combination should calculate the focal length and the power, the crown glass and flint glass. One is a crown glass, other is a flint glass. It's just a variety of glasses. This is plane, okay, it's not concave, it's plane surface. Plano concave, you can say. This is refractive index 1.52, this has got refractive index 1.66 respectively. The radius of curvature of each surface of the crown glass, whatever it is, radius of curvature is 20 centimeter. Find the focal length and the power of the crown glass, the front glass. Okay, the refractive index of the crown glass and front glass are given. Find the focal length and the power for the combination, maybe for the combination. Okay, yeah, the refractive indexes are given. Okay, so here's the sum. You know, you have to use lens makers. 1 by f is equal to nu minus 1 into 1 by r1 minus 1 by r2. For the first lens, r and r, so right side r is positive, left side r is negative for a convex lens. So then you get it like this. It will be 2 by r. 1.52 refractive index of crown glass, and the flint glass is or 1.52 for the crown glass alone. Let's find out. Okay, minus 1, which is the refractive index of air. So using the crown glass formula, you get the focal length to be 1 by 5.2 meters. Okay, so that's done. Similarly, now go to calculate the flint glass, same formula, 1 by f2, using the same lens focus formula. But in the case of a plano concave lens, you know the refractive index is given to be 1.66 minus 1. But plano concave lens, for the first lens, the radius is negative, and it is a concave lens, not a plano concave lens. According to this, it is not a plano concave. So for the second lens, the radius is positive. So therefore you get it like this. Okay, just check and write the answers. Once you get both the focal lengths, you can find the respective powers, and the total power is P is equal to P1 plus P2. One is positive, other is negative, so it will become negative. So you get the equivalent power. Calculate the combined focal length. Once you get the combined power, then reciprocal it to get the combined focal length and convert it into meters by multiplying the numerator with 100. Okay, so that's about the sum. So this is the answer. But what you have to remember, okay, what you got to remember is this is not a plano concave lens. It is a completely concave lens. It's like this. You know, for the first lens, you can see that this radius is positive, this radius is negative. For the second lens, if you see, this radius is negative, this radius is positive. So substitute these values for 1 by f1 and this for 1 by f2, and substitute the respective refractive index in the lens maker's formula. Then once you get the respective focal lengths, you reciprocal the respective focal lengths to get the respective powers. Once you get the respective powers, one is positive, other is negative, obviously. Add and get the equivalent power, and reciprocal that to get the equivalent focal length. Okay, always to get the equivalent focal length, Find the total power and then reciprocal it. Okay, so I've showed you that answer. So let's go to 18th question. Okay, next question is draw any diagram to show the formation of the image of a point object placed in a medium of refractive index n1 on the principal axis of a convex spherical refracting surface, where you know this no convex spherical refracting surface where the object is placed in n1 and n2. We call it as mu1 and mu2. They're calling it as n1 and n2. You know the whole entire convex spherical refracting surface diagram. The whole derivation alpha, beta, gamma and all those exterior angle location and everything. Just derive the formula, and you know that it will be mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. You know the derivation, we have done it in class. So let's go to 19th question. Derive the lens maker's formula for double convex lens. So you know what, and continuing that and arriving at a lens formula where it's 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. You know this is just lens makers, a continuation of convex spherical refracting surface. Let's go to the next question, which is the 19th question. The following data, some data has been given in the question. Identify the observation and give a reason for your choice. Okay, object distance, image distance. The following data recorded the corresponding values of image distance, the experiment, study of real image formation by a convex lens. A convex lens of power 5 diopter. You take a convex lens, its power is plus 5 diopter. So it's only one lens, so you can reciprocal it with power where it's 100 by 5. And so then it's 20 centimeter is the focal length of the convex lens. Now some data has been given in the tabular column, which you need to correct and see what is right. And they've said object distance is 25 centimeter. Serial number 1. Image distance is found to be 97 centimeter. Will this be true? You know the focal length, right? You can substitute and see, right? 1 by f is equal to, which is convex lens is 20, is equal to 1 by v minus 1 by u. So 1 by v is 97. Okay, 1 second. For object distance is 25, image distance is 97. Object distance will be, even for lens, it will be minus 95. And so first of all, the focal length is 20, which means this object distance is between f and c. The image will be beyond c. And so it makes sense to have such a large distance. So, but will it ever work out to 20? It will not. So then therefore this is not true. So let's take the second condition. This is given to be 30 and this is given to be 61. Will it be true? Again, you substitute like this. So 1 by 20 is equal to 1 by image distance. First of all, what is this image? Object distance is 30. Object distance is still 30, which is between f and c only. Image should be beyond c, 61 is possible, but however, the number will not get you an answer because 1 by v, 1 by 61, object distance is 1 by 30, so it will become 1 by 30 and you will never get this to be equal, so this also will not be true. So let's go to third one, 35 and 37. Similarly, you have a 45 and a 35, a 50 and a 32, and a 55 and a 30. So which of this will be working out properly? So let's see. 1 by f, which is always 20, is equal to, which of these will be correct? Okay, so let's try 1 by p minus of, okay, in this, what is this distance? 35 centimeter. That is again between f and c, and the object should be beyond c, which means c is 40. So this is definitely not correct. This is really bad. The object is between f and c, the image should have been beyond c. Okay, so that's about that. And let's look at this. This will be 1 by 20 is equal to 1 by object distance. Image distance is 35 minus plus 1 by 45 minus of minus, correct? And what is this distance? This is beyond c. Between c and f, this makes sense, and I hope we get the answer for this at least. What is 35 and 45? What will be the LCM? Oh, in this question, what has been given is one of the reading is incorrect. So I'm just marking it by calculating. These are experimental values. So more or less close, if it comes, it's okay. So you don't have to really calculate it like this. Just generally see if it's nearly matching and right answer. Okay. So that's the whole point. I understood now. So it's 25 and 97. Okay. What is the meaning of 25? Where is the object? It's between F and C. Image will be beyond C. Okay, so this is possible. 30 is also between F, object is between F and C. Image will be beyond C, which is beyond 61 is slightly 60 is the center of curvature. So maybe, but so close. This one, this is so close is number 2, but still fine. Okay, so still it's okay. So 35 is beyond between F and C again. Between F and C, the image will be beyond C, but it says 37, which is definitely not correct. This is not correct because it has to be greater than 40, but it's 37. Okay, so let's look at this. This is definitely the object is beyond C. Image will be between C and F, which is possible. The object 50 is beyond C. Image will be F and C, which is possible. Beyond C, F and C, yes, possible. So the only data which is incorrect is this data, 35 and 37. Okay, so you have to not look at it exactly by putting the formula. It's just an evaluation of where the object has to be and image has to be approximately. Let's go to 20th question. Okay, 20th question. Calculate the distance so that the real image of the object at 0,15 cm in front of the convex lens of focal length 10 cm can be formed on the same point. Okay, the real image can be same point. The radius of curvature of the mirror is 20 cm, which means the focal length is 10 cm. It has to be minus because the convex lens of focal length has been given. So there's a convex lens. The distance, calculate D. This is the distance. They have marked a concave mirror here. Okay, and they're marking this distance as D. They're marking something here which is 15 cm. Let me see what is that. Calculate the distance D so that the real image of an object at O. Where is O? I don't know where is O in your diagram. 15 cm in front of the convex lens. Okay. O, object is O. They have not marked it, but we can write it 15 cm in front of the convex lens of focal length 10 cm, which shows that the object is between F and C. Image will be beyond C on the other side, correct? Yeah. Radius of curvature of the mirror. Focal length of the mirror is minus 10 cm. This is for the mirror. So this is for the mirror. Okay. So you know that let's find with the convex lens 1 by F is equal to 1 by V minus 1 by U. That's 1 by 10 is equal to 1 by V minus of 1 by U, 1 by 15. So 1 by V therefore is 1 by 10 minus 1 by 15. The LCM is 30. So into 3 into 2. And so it's V is equal to 30. So once you get V to be 30, which is to the right side as usual, it's 30. What are they saying? Will the image be the radius of curvature? So I want to read this question again. Calculate the distance D so that the real image of an object at O 15 cm in front of the convex lens of focal length 10 cm can be formed at a point O, which means you're going to retrace. Radius of curvature of the mirror. What mirror is it? They've given it as concave mirror. Will the image be real or inverted? At the same point as the object, you have to get the image. Okay. So if it has to retrace, then the first image that you're getting, supposing the object is here, it's forming an image at 30. Okay, 30. Then this mirror should be so far away that this 30 is the radius of curvature, so that any ray passing through the if the object is at the radius of curvature, any ray passing through the center of curvature will retrace its path. It has to come then, which means I'll have to think about this once again. So can I say, since it's passing through the this distance is 30 centimeter, and let's assume that therefore this distance totally is d, right? So can I say that this is d minus 30, so therefore it's d minus 30, and suppose this is the radius of curvature, which happens to be 20, double of the focal length. D minus 30 is equal to 20. D minus 30 is equal to 20. D will be 50. So then can I say, then therefore the D itself is 50. I hope they've given the answer. Let's see. They haven't given the answer for this. Will the image be real or inverted? So it's going to be the same, because it's going to just exactly retrace its path, because any ray passing through the center of curvature is going to exactly retrace its path. Yeah, so this is right. So D has to be 50 centimeter. Okay, so if you have any discrepancy, they've not given the final answers in this book, so the assignment sheet. So this is the answer. You can cross check and let me know what is yours. Okay, so let's go to 21st question. Find the angle of deviation between the red light and the violet light produced by the flint glass prism. So a prism of refractive index 60 degree. Find the angle of deviation delta. The refractive index of the prism for the red light and the violet light are different, and colors are 1.622 and 1.663 respectively. So angle of deviation delta deviation between the red light, delta V minus delta R, is nothing but mu V minus A into mu V minus mu R. It's a formula. A into mu V minus mu R. A is 60 degree, but can I use this formula? Mu V is 1.663 minus 1.622. So 1.622 will be 0.041. A 60 degree is 0.041, and should the angle be represented, lift it like this, 60 degree, and that's what I would do. Let's see. So let's go to the next question. What's the next question? Refractive index of water, which is respect to R, is 4/3. Obtain the value of the semi-vertical angle of the cone for a fish underwater. Semi-vertical angle for a semi-vertical angle for a fish. This is a semi-vertical angle. For this to occur, this has to be grazing through the separation, and so this has to be critical angle IC. Therefore, this has to be IC, and to find sin IC is equal to sin inverse of 1 by mu. 1 by mu is 4 in the 3. So the refractive index to obtain the value of semi-vertical angle of the cone for a fish underwater. Draw an approximate diagram. That's all. So this is the fish underwater. They are asking for semi-vertical angle. This is what would strike me to do. For this to occur, this has got to graze through the separation, and this is IC. And the sin IC is sin inverse of 3 by 4, which is nothing but the semi-vertical angle is what I would write. Draw an approximate diagram. Diagram is also over. So in other words, it's going to come and fall into the ice. Okay, so next 23rd question. An ray of light PQ is incident at an angle of 60 degree. The phase of the prism of angle 30 degree, incident at an angle of 60 degrees. So you take a prism, you have an angle here with an angle of incidence of 60 degree. The angle of the prism is 30 degree. Prism of angle 30 degree as given below. The ray emerging out of the prism makes an angle of 30 degree with the incident ray. The ray emerging out, which means deviation itself is, the ray emerging out of the prism makes an angle 30 degree with the incident ray, means deviation is 30 degree. Delta. Show that the emergent ray is perpendicular to the face BC. So you're going to show that the emergent ray is going to be perpendicular to BC. Perpendicular to face BC. Yeah? Oh, so that I marked it wrongly. This is ABC. So it's going to be perpendicular. Emergent ray is going to be like this, which means 90 degree, 90 degree. If it's going to be like this, the incident ray on this face should have been like this. Okay, so then if it should have been like this, then this ray would have to go like this. I mean, let me extend this diagram. See, it should have been normal to this face, then the ray would have to go like this. So then the incident ray should have been not from here. So let's draw the incident ray like this. It's like this. This is the normal. Okay, and this is the angle of incidence at 60 degree. So then you have to find what is this angle of refraction. Since it's going normally like this 90 degree, you know that this has got to be 60 degree and this has got to be 30 degree. Write this and then come back to the question. Show that the emergent ray is perpendicular to the face. Oh, we have to show that the emergent ray is perpendicular to. Oh, so you can't draw it like this. There's something to prove, which means you know that the angle of incidence in this face, that is R2 is equal to 0 and E is also 0. That's what it means. You know that R1 plus R2 is equal to A. You know R1 plus R2 is equal to A. R1 is this 30 degree. R2 you don't know, you have to prove it, okay, to be 0, is equal to A. Therefore R2 is equal to 0. Thus you found that this R2 is 0. When R2 is 0, the normal is also like this, and so then E is also 0, and that proves it. Okay? So that completes it. This proof is very easy. Okay, let's go to the next question. Twenty-fourth question. Find the position of the image formed by the lens combination given in the figure. Okay, so you have a convex lens, have a concave lens, and you have another convex lens here, and the focal length of this is plus 30 centimeter. The focal length of this is minus 10 centimeter. The focal length of this is plus 10 centimeter. The object is distant 30 centimeter from the first focal length, which is beyond C. The separation is given to be 5 centimeter, and this separation is given to be 10 centimeter. Considering that this object is at 30 centimeter, which is beyond C, you get between F and C. Let's take the first lens. 1 by F is equal to 1 by V minus 1 by U. 1 by 10 is equal to 1 by V minus 1 by minus 30. So 1 by V therefore is 1 by 10 minus 1 by 30. The LCM itself is 30. So 3 minus 2. So 3 minus 1, 15. So V is equal to plus 15. So you know this itself is 5. This is the initial image is obtained here. For the second lens, this is going to serve as your image object. So if this is going to be at this distance, you have to reduce this 5. And so then from 15 you reduce 5, it will be 10 centimeter, which is nothing but the focal length of the second lens. For the second lens, its focal length, the image will be at, therefore at infinity. And for that is going to be the object for the third lens. And so the final image will be also 30 centimeter to the right side of the convex lens, which is at the focal length of it, okay, plus 30. So that completes the sum. So let's go to the next question, which is the 25th question. One of the bases of the refracting angle of the prism is there. Refractive angle is 30 degree, and the refractive index is 1.414. Root 2 is silvered. So one of the faces has been silvered. Okay, at what angle must a ray of light fall on the unsilvered part, so that after refraction into the prism, the refraction at the silvered surface, it retraces its path. If it has to retrace, this has to fall normally. only then it will come back like this, whatever goes, and then so it has to go like this. Okay, so then this is 90 degree, so therefore this has to be 60 degree. You do a normal here, the light ray which is falling like this. Okay, what should be this angle of incidence? This is 30 degree. Take this refractive index, this is sin I by sin 30. Okay, so sin I therefore is sin 30 into refractive index, which is 1.414. What is sin 30? Is just 1 by 2 into 1.414. Okay, so it will be 0.707 or something like that will be your sin I. So I therefore sin inverse of 0.707, and that will be my angle of incidence. So let's go to 26th question. A thin lens made up of material of refractive index mu has a focal length f. If the lens is placed in the transparent medium of refractive index, where the refractive index of the medium is lesser than the refractive index of the material. So the medium in which you are placing is actually lesser than, just like glass placed in water. Makes sense, right? Obtain an expression for change in focal length of the lens. Use the result to show the focal length of the lens becomes, becomes mu w into mu g minus 1 by mu g minus mu w. Some proof like this when you are placing a denser medium in a rarer medium. Okay. Supposing I have a lens in air. Okay, in that case I know 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2, which is mu of glass. Okay, so suppose I take that glass and put it in, this is in air, so this is with respect to air. But I'm now going to place the glass and say water, which is a rarer medium. In that case, you know that 1 by f is equal to, or 1 by f1 or new focal length f dash is equal to mu of glass with respect to water minus 1 into 1 by r1 minus 1 by r2. So in that case, I'm just trying this. Okay, in that case, can I write this as mu of glass by mu of water minus 1 into 1 by r1 minus 1 by r2. So this is my new focal length. Okay, and so this is my new focal length, and so now let's find the difference in focal length between the first one and the second one. So what is the first one's equation, which the focal length will increase in this. Okay, so this answer will decrease. So let's subtract the first equation first. 1 by f minus 1 by f dash, 1 by f minus 1 by f dash, which is mu of glass with respect to air minus 1 into 1 by r1 minus 1 by r2 minus mu of glass with respect to air by mu of water with respect to air minus 1 into 1 by r1 minus 1 by r2. So let's try doing something with this to get the answer. So will I get mu of glass with respect to air by r1 minus 1 by r1 minus mu of glass with respect to air by r2 plus 1 by r2, and then here also you will have mu of glass, let's take LCM, mu of glass with respect to air. Now it's getting very complicated here. So when I subtract, what is that I should get? Just 1 second.